this video takes you through the worked out solutions to the fourth and final page in the review packet. Number 12, the directions say find the product. When it says find the product, it means I am multiplying two things together. Okay? So looking here, if I multiply negative 8x times x minus 9, I can just distribute. Negative 8x times x is a negative 8x squared. Negative 8x times 9 is a positive 72x. Over here, I'm multiplying two binomials this time, so I can do it two methods. I can either use the FOIL method or I can use the area model. If I use the area model, I have 3x minus 1 and 3x plus 1. 3x times 3x gives me 9x squared. 3x times a negative 1 gives me a minus 3x. 1 times 3x gives me 3x, and 1 times negative 1 is a negative 1. Now, I have all of these terms that I need to add together, and I can only add like terms, so it ends up being just these guys that I can add together. Those add to be 0, so my final answer is 9x squared minus 1. The other option is to use the FOIL method, and when you do that, you do your first 9x squared, your outers plus 3x, your inners minus 3x, and your last minus 1. We notice we get the exact same terms. Now when I combine like terms, I get 9x squared minus 1 as my answer still. Switching down here to number 13. Number 13, every single one of these is asking us to write the equation in standard form. So this is a function, means we have y equals each time. Our final answer is going to have y equals in it. Up here, the original expression didn't have y equals, so I didn't have y equals in number 12. Now, to write it in standard form, remember standard form is y equals ax squared plus bx plus c. So when I look at this first one, if it's in an intercept form, I need to multiply these out to get it into standard form. Again, we can do it two methods. We can use the area model, which we would have x minus 9 times x plus 6. We get x squared, x times negative 9 is a negative 9x, plus 6x minus 54. 6 times negative 9 is a negative 54. We can then combine like terms, and our final answer would be y equals, we got our x squared, if we add those, minus 3x minus 54 as our final answer. Or we can use the FOIL method. If we start off with x minus 9 times x plus 6, we can do our first, x times x is x squared. Our outers, x times 6 is plus 6x. Our inners, negative 9 times x is negative 9x, and our last, negative 9 times 6 is negative 54. I still need to combine like terms, and I still get the same answer as I did before with the area model. Looking over here, this looks a little different because I have an a value that's not equal to 1. There are two ways you can handle this. I'm going to choose to multiply the negative 3 times the first set of parentheses, but you could have multiplied these two out first and then distributed negative 3 at the end. So if I do it this way, negative 3x plus 12 will be my first set of parentheses now. And now I can multiply this out. You can do FOIL. I'm going to do this one with the area model. I'll do the next one with FOIL. You should get the same answer either way. X times negative 3x is a negative 3x squared. X times 12 is plus 12x. Negative 2 times negative 3x is a positive 6x. And negative 2 times positive 12 is a negative 24. And when I add those like terms, I bring down that y equals my negative 3x squared plus 18x minus 24. Over here, I need to recognize that when I square a binomial, I'm really just multiplying that factor times itself. And now that I have expanded it like this, I can simplify this expression or multiply it out using the distributive property, which is FOIL, or the area model. Because I did the area model in the previous one, I'll do FOIL on this one. X times x gives me x squared. X times 3 gives me plus 3x. My inners would be plus 3x, and my outers would be plus 9. When I combine like terms, I get y equals x squared plus 6x plus 9 as my final answer. Again, make sure you have a y equals on each of those. And then finally, number 14, I'm looking at a table and I want to write the equation in different forms. So in order to do that, I need to find the pattern in the table. I notice that each time x is increasing by 1, that doesn't change the whole way through. Here I'm minus 14, minus 10, minus 6, minus 2, and now I'm adding 2, adding 6, adding 10. The second difference, I notice I'm adding 4 every single time. This means that it's quadratic. If I want the equation in vertex form, then I have y equals the a value will be the second difference divided by 2, or 2 times, I need to find the vertex. So the vertex is where we are symmetrical about, or where we change from decreasing and increasing, so I'll put a v there. So if it's 4 and negative 2, I'll do x minus 4 squared and then a minus 2. Then it says write the equation in intercept form. Well, intercept form, I need the x-intercepts. And there you go. So now I still have that same a value, 2 times x minus 3, x minus 5, because the intercepts were positive 3 and positive 5. To convert it to standard form, I just start from either one of those and convert to standard. I'm going to go with intercept form because I do think that's easier. 2 times x minus 3 times x minus 5. This time I'm going to show you how to do it a little different than the previous one. Up here, I distributed that number first and then use the area model. This time, I'm going to multiply the binomials first and distribute at the end to show you that you can do it 2 different ways. So I'm going to multiply these first. Okay, when I do that, I can use the area model to the side here. X minus 3, x minus 5. X times x is x squared. X times negative 3 is a negative 3x. Negative 5 times x is a negative 5x. Negative 5 times a negative 3 is a positive 15. And again, I can add these like terms to give me, carry that 2 down, my x squared minus 8x plus 15. My last step, now I'm going to distribute the 2 at the end. So in the previous one, I distributed the 2 first. Now I'm doing it at the end. You can do these either way. Alright, and then the final one over here, give the domain and range. The domain is going to be all real numbers. We're not restricted by the domain. But if I do a quick sketch of the graph, I think it's easiest to look at vertex form. We translated right 4 down 2, so something like that, or the x-intercepts would be 3 and 5. So we're going to have a graph that looks like this. Notice that if this is 4 comma negative 2, it does have a minimum value. That minimum value occurs at the vertex, and that y value is negative 2. So it's negative 2 or anything above for our y value, so y is greater than or equal to negative 2. And that completes the last video for this review.